Okay, so we're going to talk a little bit more about electric current than power. And DC is direct current. That would be like a battery. It just produces a current in one direction. Alternating current, the electrons move first in one direction, then the opposite direction, to and fro, relatively fixed positions. Alternating current is used more often because energy can be transmitted a great distance without much heat loss. You can convert between alternating current and direct current with a diode. Only half the cycle gets through. It's important to realize that it's not the electrons that are moving as fast. You know, you flick on a switch and your light turns on. It's not like an electron is making its way over to the lamp and that's what's happening. It's the energy that's being transmitted. And so the source of electrons in a circuit would be in the wires, it would be in the lamp filament, but again, it's the energy that's being transmitted, not the actual electrons. Okay, electric power, charge moving in a circuit does work, and rate at which that work is done is power, so that should sound kind of familiar to you. Electric power is current times voltage. And to get that standard international unit, you need volts for the voltage and amps for current. And so 1 watt is an amp times a volt. So a lamp rated at 120 watts operates on a 120 volt line. What would the current be? 1 amp of current. And of course you could say what a 60 watt lamp draws on a 120 volt line. Oopsie. 60 watts and 120 volt. What is the current? And of course that would be 0.5 amps. The current would be 0.5 amps. A kilowatt hour is how you are charged on your energy bill. It's the energy consumed in an hour at the rate of 1 kilowatt. So probably an average cost might be 11 cents per kilowatt hour. That would be a typical cost. How much would it cost you to run a 100-watt light bulb for 10 hours? Okay, well, 100 watts is 0.1 kilowatt, right? Then we multiply it by 10 hours, and we would get 1 kilowatt hour at a rate of 11 cents per kilowatt hour. So it costs you about 11 cents. So the next time your parents tell you to shut off the light, you can do the math for them. It costs about 11 cents. Electric circuits, you're going to have a complete path or circuit for that energy to get around from a positive to a negative terminal. If there's any kind of gap, like a switch, for instance, we flick the switch, we open the circuit, the electron flow stops, or the energy stops, and we break the circuit. Now circuits can be series or parallel. Here's a schematic of what's really going on. So when I say resistors later on, you can think of those as little light bulbs, and this is how they would be drawn in a schematic. And these are batteries, so we're going to hook these up to 12 volt, 24 volt batteries, and that's what we're talking about. In a series circuit, current flows through all the lamps. So if you've seen the Christmas Vacation movies, he puts all those lamps up and it doesn't turn on. He says, well, let's check all the lights. Well, that kind of was the old way of doing things. Now, they don't make the series circuit. Well, they might make them, but most people don't get those. So if one bulb goes out, you don't disrupt the flow of all of the. This is kind of an explanation of what's going to happen, how we're going to calculate the resistance, so you can read through that. But what's going to end up happening for a series circuit is that the resistance of the circuit is going to be the resistance of all added up. So the current is going to be the same for each resistor. The voltage will be different across each resistor, but you're going to add those up to get a total voltage. And the resistance of the circuit is the sum of all the resistors in that circuit. So for instance, we had a 12 volt storage battery connected to 3 resistors. So again, just kind of think back to that picture earlier. And how can we calculate the equivalent resistance, the current in the circuit and the current in each resistance or resistor? Okay, we're going to have 8 ohms plus 10 ohms plus 12 ohms for a grand total of 30 ohms for that circuit. And that's going to be in the circuit and through each resistor. So how are we going to calculate voltage? We don't have a ton of room here, really. So we have 30 ohms of resistance total, and remember that current is voltage over resistance, and so we're going to take our 12 volts, put it over 30 ohms, and we'll get 0.4 amps of current. And that current is in the circuit and the current in each resistor. Now, parallel circuits are set up differently. The current outside the branches is equal to the sum of the current values in the branches, so we're going to have a schematic similar to this. This would be a pretty common kind of circuit. The voltage is the same through each resistor, the same brightness, but there are 3 separate paths. So we have a third of the resistance, if they're equal resistance, between the terminals, and so we have 3 times the current. So a battery putting out 3 times that energy will die that much more quickly, or go dead. Okay, this is going to our equation here of getting a resistance in a parallel circuit. The resistance will be 1 over the resistance for the circuit equals 1 over the first resistor, the second resistor, and so on. Okay, so as an example, let's take these 3. We've got a 6.8 ohm resistor, an 8 ohm resistor, and a 16 ohm resistor connected in parallel across a 24 volt battery. What is the resistance of the circuit and what is the current in each resistor? Okay, so if we find the equivalent resistance, we're going to go 1 over 6.8 plus 1 over 8 plus 1 over 16, and definitely do this calculation. You're going to get 3 ohms of resistance. So if you add these all up, then you take the reciprocal, you'll get 3 ohms. So what about, so that's the resistance of the circuit. What is the current in each resistor? Okay, so what we're going to have to do, we're going to take that, and let's find the current in the 6.8 ohm resistor. All right, I'm going to take the 24 volts over the 6.8 and 3.53 amps of current through that resistor. I can do the same thing with the 8 ohm, and we will get 24 volts over 8 ohms, 3 amps of resistance. Okay, and then I could do the resistance of the 16 ohm by just doing 24 over 16, and those are going to add up to the total of 8 amps, which I did not do for you. So let's go ahead and do the total. I got the 3 ohms of resistance, but let's do the total current. The total will be the 24 volts over 3 ohms. So I'll get a total current of 8 amps. And then I can go back and individually do it just like I showed you. The 24 divided by 6.8, the 24 divided by the 8, and the 24 divided by the 16. And that will all add up to 8 amps. Okay, we can also combine these. This is an example. But here's an example of equivalent resistance for something that's very has 2 things in it. It has a parallel and a series. These right here are in parallel. So if I do this aside, if I come up here and I say, all right, well, let's do these 2 first. These 2 are in series, and so to find the resistance there is just going to be 6 plus 2. So here I have 8 ohms of resistance. Now this right here is in parallel, so I'm going to take the 8 ohms and the 4 ohms, and I'm going to do a parallel resistance. So to find this, I'm going to break this down. What I will find is 1 over the resistance here is going to be 1 over 8, which I got right here, plus 1 over 4, which is right here. And so what I get there when I do the calculations, I should get an R equal to 2.66 ohms. So what we're saying here, is I'll change the color, is this right here is going to give us a resistance of 2.66 ohms. Now the rest of it is in series. So to find that, all I have to do is I'll start right here and go around. 3 plus 6 plus that 2.66 plus the 1 equals the 12.66 ohms. And I know it's hooked up to a 9 volt, so I could go through and I could find amps as well. The last thing I want to talk to you about is blowing a fuse. This is the voltage that is impressed by the generators at the power plant, and this voltage is applied to our appliances connected to our wall outlet. We can get a possible overload. So you have too many things going right there. Got the total line current increases to the total amps they all need. Fuses are connected in series so that the current must pass through those fuses, and if there's too much, remedy the problem by breaking the circuit, and then you have to put the circuit back on. And that is it.